Today we are reviewing rates, proportions, and percents. We're going to go ahead and start with rates and ratios. So to find a unit rate, which is how many for one thing, divide the two numbers. The label per tells you the order for dividing. So for example, 50 miles in 2 hours is 25 miles per hour. Miles per hour means miles divided by hours. When solving problems with ratios, setting up a proportion is a good strategy for most of these problems. All right, let's take a look at one. A 4.5 ounce hamburger patty has 25.5 grams of protein, and 6 ounces of fish has 32 grams of protein. Determine the grams of protein per ounce for each type of food. Okay, so here's the order we're dividing. Protein per ounce. Okay, so protein comes first. We're going to start with hamburger patty. So we have 25.5 divided by, and this is grams. I guess I should have said grams of protein per ounce. 25.5 grams, and then 4.5 ounces. Okay, so now we need to divide 25.5 divided by 4.5. So to do 25.5 divided by 4.5, we need to make these mixed numbers into improper fractions. So 2 times 25 is 50, plus 1 is 51, so we have 51 halves divided by, and then we have 2 times 4 is 8, plus 1 is 9, so 9 halves. Okay, then we do keep, change, flip. So we keep it 51 halves. We change it to multiplication, and then we flip our last one. I'm going to go ahead and cross cancel here since I see I have 2's. 2 divided by 2 is 1. 2 divided by 2 is 1. So when I multiply it out, I have 51 ninths. And then I need to make it back into a mixed number. So I'm going to set up my division. It doesn't divide evenly, so I'm going to just write it out. 9 goes into 51 5 times. 5 times 9 is 45. 51 minus 45 is 6. So I've got 5 and 6 ninths. Still not fully simplified because I can divide those guys by 3. All right, so fully simplified is going to be 5 and 2/3 grams per ounce. Okay, go ahead and pause the video and try fish on your own. All right, let's check your answer. So we have 32 grams of protein for the fish. 32 grams. And then we have 6 ounces. This one we don't have to worry about all of our fraction division. We can just jump right to a problem that looks like this. 32 divided by 6. 6 goes into 32 5 times. 2 as a remainder. So we have 5 and 2/6, which can be divided by 2. So that makes it 5 and 1/3 grams per ounce. So if I had to compare it, the hamburger patty has a little bit more in terms of grams of protein per ounce. But here they didn't say to compare it, they just said to find the unit rate. All right, let's take a look at our next one here. A scale on a map shows that 5 centimeters equals 2 kilometers. Part A, what number of centimeters on the map represents an actual distance of 5 kilometers? Okay, we're going to use a proportion to help us with this one. 5 centimeters equals 2 kilometers. That's going to be my first half. This is my scale. Scale has two different labels, and it's a comparison in simplest form, 5 centimeters to 2 kilometers. Now I want to know how many centimeters for 5 kilometers. When you're setting up proportions, you need to have the labels line up. So I put centimeters on the top and I put kilometers on the bottom. I like to look for multiplication patterns, easy ones, side to side, up and down. I don't see an easy pattern here, so I'm going to do cross products. 5 times 5 is 25. 2 times x is 2x. Then I divide both sides by 2. 25 divided by 2 is 12.5. So x equals 12.5 centimeters. Make sure you go back to the original question. Make sure you've got the right label in there. What number of centimeters? 12.5. Okay, then for part B, it says, what is the actual kilometers that is represented by 2 centimeters on the map? Okay, so let's get it set up. 5 centimeters, 2 kilometers, and now it's 2 centimeters for x. Okay, go ahead and pause the video, finish solving that one on your own. Okay, so let's go ahead and check. I'm going to do cross products again. 5 times x is 5x. 2 times 2 is 4. All right, so I'm dividing by both sides by 5. So I have x. I could write that as a fraction, 4/5. Or, if I wanted to, I could do 4 divided by 5. 5 goes into 4 a 0 amount of times. But 5 goes into 48 times. So I could write 8/10, either one, kilometers. All right, let's take a look at our next one. A train traveled 1/5 of the distance between 2 cities in 3/4 hours. At this rate, how many hours will it take the train to travel the entire distance between these cities? Okay, so we're going to set up a proportion here. 1/5 distance for 3/4 of an hour. We want to know for one whole distance, because the whole trip is just 1. We want to know how many hours. Okay, on this one I'm going to use a multiplication pattern. I know 1/5 times 5 equals 1. If I did 1/5 of the distance, 5 of those will get me to the total amount of time. So now I can do 3/4 times 5 to figure out what the total time will be. So let's see, 3/4 times 5 over 1. When I'm multiplying with fractions, they do need to be written with just 2 parts, so I have to write it as 5 over 1 instead of 5. Okay, let's multiply straight across on this one. 3 times 5 is 15. 4 times 1 is 4. 4 goes into 15 3 times. 3 times 4 is 12. We subtract to get 3. So I have 3 and 3/4 hours, which is C. All right, let's try this next one. The directions on a bottle of vinegar say mix 1 cup of vinegar with 1 gallon of water to make a cleaning solution. The ratio of vinegar to water is 1 to 16. So this means 1 part vinegar for 16 parts water. All right, let's see. How many cups of water should be mixed with 1/4 cup of vinegar to make the cleaning solution? All right, so let's get it set up. So 1/4 cup would be the vinegar. And then we don't know how much water. We're just going to put W for water. All right, go ahead and pause the video. Finish trying this proportion on your own. Okay, let's go ahead and check our work. This one I'll do cross products for. 1 times W is W. 16 times 1/4 is like 16 divided by 4. If I made this into a fraction, 16 over 1 times 1 over 4, I get 16 over 4, which is 4. So 4 cups of water. Let's take a look at this next one. How many fluid ounces of vinegar should be mixed with 80 fluid ounces of water? So 1 part vinegar, 16 parts water. Doesn't matter if it's cups or ounces or whatever. Okay, so now I'm looking for vinegar. 80 ounces of water. Okay. Let's see. I think I'll do cross products on this one. 16 times V is 16V. 80 times 1 is 80. I'm going to divide both sides by 16. Vinegar equals, okay, let's see, we've got to do 80 divided by 16. All right, 16. Let's see, if it was 15, 15 times 6 is 90. So maybe 16 times 5, just as a place to start. Let's see. 6 times 5 is 30. 5 times 1 is 5 plus 3 is 80. Look at that, it goes in perfectly evenly. So vinegar is going to be 5 fluid ounces. All right, let's look at this next one. Proportional relationships. So for a proportional relationship, both variables change at a constant rate. So movie tickets cost $10 each. So here I have a table that shows that. For 0 tickets, it costs $0. 1 ticket, it costs $10, and so on. Here's what a proportional graph looks like. I have a title. I have cost on the side. I have number of movie tickets on the bottom. If it is a proportional relationship, the graph must be a line that goes through the point 0, 0. The equation for a proportional relationship is y equals kx, where k is our constant of proportionality. Okay, so for this one, that constant would be 10, and the equation would be y equals 10x. So let's look at this next one. Select each option that represents a proportional relationship between x and y. Okay, so in order for it to be proportional, it means it has to have a constant. You're multiplying by the same thing every time. Okay, so let's see. For this one, I have 1 1/2 and 6, 3 1/2, 1/4 and 13, and then 7 and 28. So I know just from the last one, 7 times 4 equals 28. So these other things need to be times 4 as well in order for it to be true. So let's see. 1 1/2 times 4. Is that going to give me 6? So let's see. We have 3 over 2 times 4 over 1. We get 12 over 2, which is 6. Okay, so that one works for times 4. Let's check with 3 and the 4th. 3 1/4 times 4. So 12 13 fourths times 4 over 1. Okay, let's see. These guys cross cancel, gives me 13 over 1, which is the same thing as 13. Okay, so this one works. Our constant on this one is times 4. All right, constant has to be multiplication or division. So here, to get from 4 to 1, we would divide by 4. Well, 5 divided by 4 is not 2, so I can stop right there. I know it is not proportional. For our equations, y equals 7/8 x. If it's a proportional relationship, I have y equals a number times x. That's true for C, so that is proportional. D, y equals x plus 1. No, that's not proportional because we have this x plus 1 part. It would just have to be like y equals x or y equals 2x to be proportional. All right, E. No, that doesn't work because it's not a straight line through 0, 0. F is a straight line through 0, 0, so that one works. So we have F and C and A that are all proportional. All right, let's see. Which relationships have the same constant of proportionality between x and y as the equation y equals 1/3 x? Select each correct answer. Okay, my constant here is the 1/3. The number in front of the x, that is your slope, that's the constant. So we're looking for which other ones have that same relationship. Okay, so A, not going to have a constant of proportionality because it doesn't go through 0, 0. So we know right away A isn't going to be a correct answer. All right, 1/3 x. So over here I go up 3/1. That would be y equals 3x. Nope, that's not the same as 1/3 x. Let's look at C. Here's a point. Up 1/3. So that one means the same thing as y equals 1/3 x. 3 times 1/3 gives you 1. Okay, so that one works. C works. For D, needs to be y equals 1/3 x. So let's see if one of these things works. -4.5 equals 1/3 times -1.5. All right, let's see. 1/3 times -1, I'm just going to make them both into fractions. Let's see. 2 times 1 is 2, plus 1 is 3. 1/3 times -3/2 gives me -3/6. And that's going to be -1/2. So, no, that's not going to be an appropriate relationship here. So 1/3 of this value is not going to equal this value. So no, that's not going to be a correct statement. So D is not going to work. Let's try X. All right, let's see. We've got 1.5 and 1/2. Let's do this one because we just did 1.5 over here. 1/2 5/10 equals 1/3 times 1.5. Now I know 1/3 is the same thing as divided by 3, so in this one I'm just going to do it this way. 1/5 divided by 3. 3 does not go into 1 a whole number of times. It does go into 15 5 times. We said we would get what? 5/10, we got 5/10. So this one is going to work, and that's true for all of these. If I took this and divided by 3, I get the 1 at the bottom. So for this one, it's going to be C, and it's going to be E. Let's look at problem number 9. Okay, so for number 9 here, or our next problem, I should say, is which equation has the same constant of proportionality equal to 4? So when we have a constant of proportionality equal to 4, it means like this. This is what the equation would mean. Y equals 4 times x. So in order to see the constant, we've got to solve them for y. So let's see. 4y equals 4x. We divide by 4. We divide by 4. That gives me y equals x. My constant on A is 1. So nope, that doesn't work. Let's try the next one. 4y equals 12x. We divide by 4, we divide by 4, we get y equals 3x. Nope. 3y equals 4x. We divide by 3. We divide by 3. We get y equals 4/3 x. Nope. So let's hope the last one works. 3y equals 12x. We divide by 3. We divide by 3. We get y equals 4x. So it's this last one that has that same constant of proportionality. All right, let's take a look at our next problem here. All right, so it says the numbers of parts produced by 3 different machines are shown in the table. Only one of the machines produces parts at a constant rate. Which equation represents y, the number of parts produced in x minutes for the one machine that produces parts at a constant rate? Okay, so we need to figure out how many parts per minute and see which one's the same. Okay, so here, from this minutes here to the machine Q, this one is 1 times 9 to get to 9. 3 times 9 does not equal 18, so machine Q is not going to work. Let's take a look at machine R. 1 times 8 would give us 8. 3 times 8 equals 24. 9 times 8 equals 72. So that one looks like it works. Let's just double check on the last one. This would be 1 times 6 to get 6. 3 times 6 equals 18, so that works. 9 times 6 does not equal 52. So machine R is the one that is proportional. Our constant is 8. That's what we multiply by. So it would be y equals 8x. Let's take a look at this next one. The graph shows the distance in miles d a car travels in t. Explain why the graph does or does not represent a proportional relationship between the variables d and t. Go ahead and pause the video and answer this question on your own. Okay, let's check it. We said for proportional relationships in a graph, it needs to be a straight line, and 0 goes through 0, 0, and that's true for this. So yes, it is a straight line through 0, 0. All right, so moving on into slope. There are 4 types of slope. Positive slope goes down from, looks like it's rising from left to right. Negative slope looks like it's going down. You can also change it into a capital N. 0 slope is flat like the floor. You could change it into a capital Z. Undefined slope goes straight up and down. You could take it and make it into a U. All right, so let's find the slope of these lines. If it helps, you can put in a step. If you see the graphs are going by ones like this one, then you can count the rise and the run. So here we're going up 2, rise over run, graph slope, the rise goes on top. How far up and over? 1, 2, 3, 4, 5. 2/5 is my slope. Just like any other fraction, you do need to put it in simplest form. However, slope is not a mixed number and is not a decimal unless it's for a story problem situation. Okay, go ahead and pause the video. Try number 2 on your own. Okay, let's check our answer. Here we can't count boxes because this is not going by ones. So we have to look at value. So here we start at 5, we go up to 8. That's going up 3. And then over here it's going from 1 to 2. So that's going over 1. 3 over 1 simplifies to a whole number 3. For slope, you can make it a whole number. You just can't make it a mixed number. Okay, percents. When we did percents, we looked at how you can do either a proportion or an equation. If you do the proportion, our keyword is tells us the part, of tells us the whole, and then percent over 100. So is over of equals percent over 100. In an equation, the part, which is equals the percent as a decimal times the whole, which is our of word. All right, and then when we are asked for a percent change, we subtract, we find the difference, and we divide by the original amount. So let's try a couple percent problems. A teacher surveyed students in 4 classes to determine the location for a field trip. Each student chose only one location. The table shows the number of students from each class who chose each location. Determine the percent of students in each class who chose the museum. What is the order from greatest to least for the percents for each class? Okay, so they're asking us 2 things. First thing, we need to figure out the percent, and then the second thing we need to do is order greatest to least. Okay, so the first thing we need to do in order to do our percent is know how many kids are in the class. So if we add these together for class E, we have 17 plus 10 is 27 kids. Out of those 27, the ones that chose the museum, that's 9. All right. So if I want to do percents, and I'm taking a fraction and I'm making it into a percent, and we can use calculators for this if we knew to. We do 9 divided by 27. That's what that fraction bar means. We get 33 hundredths repeating as a decimal, which is 33 and 3/10 repeating percent. Okay, let's try class F. 11 plus 11 is 22, plus 8 is 30. There are 30 kids in this class. 11 of them chose the museum. Okay, so we do 11 divided by 30. We get 36.6 repeating percent. All right, I'm going to pause right there. Go ahead and finish for the last 2 classes, and then order the classes greatest to least. Go ahead and pause the video and try these on your own. All right, let's keep going. 12 plus 8 is 20, plus 5 is 25. So you should have had 8 over 25. 8 divided by 25 gives us 32%. And class H, let's see. 6 plus 8 is 14, plus 10 is 24. And then we had 10 for the museum. So 10 divided by 24 gives us 41.6%. Repeating. Okay, greatest to least, greatest was H. The next biggest was F. The next biggest was E. And then the smallest was G. All right, next problem. A store owner paid $15 for a book. She marked up the price of the book by 40% to determine its selling price. What is the selling price in dollars of the book? Okay, so if we're marking up the book 40%, there's 2 ways to do it. One is to say, okay, well, the people who buy it have to pay 100% of the cost, plus the extra 40% that's being charged. So they're really paying 140%. So we can do 140% as a decimal times that original price to get our selling cost. So let's see, 1.4 times 15 gives us $21. The other way we can do it is to find 40% of $15 and then add that onto the price of $15. That also works. Part B, a customer buys a different book that has an original selling price of $38. The book is discounted 25%. The customer must pay a 6% sales tax on the discounted price of the book. What is the total amount in dollars that the customer pays for the discounted book? So we need to find the discount price and then pay 6% sales tax because the 6% is not on the 38. Okay, it is a discount of 25%, which means you're paying 25% less. So I do 100% minus that 25%, and I get 75% is how much I'm actually paying from the original book cost. So I do 38 times 75% as a decimal, which is 7,500. So let's see, 38 times 0.75. Whoops. I'm just typing that up. Let's try it again. 38 times 0.75. Get $28.50. That's the new price of the book, but that's not with the sales tax. So for the sales tax now, I'm going to do my $28.50, and I'm going to multiply times my sales tax here, which is 0.06. Okay, $1.71. So that's the tax. That's not the total. So to find my total, I've got to do $28.50 plus 1.71. Okay, and then I need to add those together, which is going to give me a total of $30.21. All right, last problem here. A worker has to drive her car as part of her job. She receives money from her company to pay for the gas she uses. The table shows a proportional relationship between Y, the amount of money that the worker receives, and X, the number of work-related miles driven. Okay, so we've got a table here. How many miles, how much money? And they say this is proportional. Part A, explain how to compute the amount of money the worker receives for any number of work-related miles. Based on your explanation, write an equation that can be used to determine the total amount of money, Y, that the worker receives for driving X work-related miles. Okay, so they're asking you to find the constant of proportionality. What are we multiplying by to get from here to here? And then they're asking you to write it as an equation. So go ahead and pause the video, try just part A on your own. Okay, let's check our answers. So you can pick any pairs of numbers that you want. I'm just going to pick this first row. I know if it's a proportional relationship, it's going to fit into this category. Y equals K times X. My Y on this first one is $12.75. I don't know my constant. My X is 25. So I have to solve to figure out what that constant is. What are we multiplying 25 by to get to $12.75? It's something less than 1 because the number of values is getting smaller. So I'm going to divide. All right, so let's see, $12.75 divided by 25 gives me 51 hundredths. Okay, so my equation is going to be Y equals 51 hundredths X. Let's check it for another one. Let's do 40. If I did 40 times 0.51, do I get the answer there that they give me? 40 times 0.51 equals 20.4. Yes. Okay, so that does work for that one. I could do it for all of them, but I'm just going to check on the one. Okay, so that's part A. There's my equation. Part B, on Monday, the worker drove a total of 134 work-related and personal miles. She received $32.13 for the work-related miles she drove on Monday. What percent of her total miles were work-related on Monday? Show or explain your work. Okay, so the first thing we need to do is use this $32.13 to solve for how many miles that were work related? She actually did. Okay, so this money is our y value. I'm going to put it in my equation. 32.13 equals 0.51 times x. We're going to divide both sides. Okay, so let's see how many miles that is. If I do $32.13 and I divide by that 0.51, the 5100s, I get 63. So that's 63 work miles. She did a whole total of 134. Okay, so then I'm going to do 63 over 134. 63 out of my 134 miles are going to be work related. Okay, so let's go ahead and divide. 63 divided by 134 is approximately 47th, and it's like 0.01. I'm just going to round to the nearest whole number, 47%. And then they said show or explain. So since we showed it, then that's really all we need to do.